Hey there, I'm Austin, the head of content and community at Fritz AI. Today in this tutorial, I want to show you how to add a simple AR effect to one of our pre-trained segmentation templates. Specifically, this tutorial will demonstrate a really basic example of applying a 2D animation to a segmented object. In this case, a holiday or evergreen tree, using our pre-trained evergreen tree segmentation template. The final result will look something like this. Now, a bit of context here before we get started. Our collection of pre-trained Lens Studio projects allow you to quickly download and experiment with unique machine learning tasks inside Lens Studio. This is a great way to learn what different machine learning tasks do, how they can be used in lenses, and how they can actually be used as triggers for unique and immersive AR effects. We currently have 14 of these templates available across image labeling or classification, object detection, and image segmentation. Check out the link in the description below for more about working with these templates. To get started, log into your Fritz AI account or sign up for free beta access if you haven't already, and create a new project via the left-hand drop-down menu. Give it a name and make sure you have pre-trained selected as your project type. This will allow you to explore and access all 14 pre-trained projects. We want to download the tree segmentation project, so we'll click into the segmentation tab here, find the correct model, and download the Lens Studio project template. This will help us start from a Lens Studio project with the ML model already pre-configured, instead of manually hooking and wiring everything up. Upon launching the project, we can see that the template already has a slider UI object connected to a color changing effect. This is simply meant to demonstrate what segmentation actually does, but to achieve our desired effect, we'll want to remove these elements from the template. So first things first, let's disable the color slider, which we can do by unchecking the UI color picker script under the slider orthographic camera object in the objects panel on the top left. We don't need to delete or remove anything for the purposes of this tutorial, but if you've got bigger plans for your lens, it might be good to clean some of this up. For the sake of this demo tutorial, I'll only add a single decoration, quote unquote, to my tree, an animated sparkle GIF via Giphy. Additionally, it's going to be a global effect covering the entire segmented tree. Anything more precise, i.e. at a pixel level, would likely take some more advanced scripting. Note that this is a GIF with a transparent background. That's because we don't want the GIF background itself to block out the tree fronds behind it. Of course, this asset can be anything you want, whether it's a static image or something more complex. First, we need to simply drag and drop this asset into the resources panel. Now that we have our AR decorative effect ready to go, we need to figure out a way to attach it to the tree's segmentation mask, or the output of the ML component. We're going to do this via the primary segmentation material, which is included in the project template, Fritz segmentation texture. Because we're using a 2D asset, we'll need to add a new 2D texture parameter node to the material graph. This is how we'll bring in our new texture, in this case the animated GIF, to layer on top of the segmented tree. We do this by selecting the Fritz segmentation texture material, opening up the material graph editor, and creating a new texture parameter node. I've decided to change the name of this new parameter to mask for simplicity's sake, but you can use whatever naming conventions you prefer. Currently, our new node is sitting off on its own, so we need to hook it up in the material graph so that it's ultimately connected to the shader. You'll notice that there's already a 2D parameter, mask color, connected to the mixer, which in turn hooks everything up to the shader. This is the parameter that was helping us apply the solid color effect to the segmented tree when we first opened up this template. With this information, we know that this is where we need to connect our new 2D texture node. Now, because all I want to do is add my animated GIF as a layer on top of the tree, I can remove the mask color parameter entirely and simply connect the new parameter to the mixer. Now, if you want to add more than one effect to your tree, you'll need to, at minimum, add a multiply node, hook up each unique parameter to it, and then connect that multiply node to the mixer. Now, in the material inspector, you'll have to create a new graph parameter called mask. Set this parameter to the asset we imported earlier, in my case, the GIF. From here, we can play with, among other things, different blend modes to see what works best for a given effect. As you can see above, I've chosen add. This is just visually what I preferred for this example, but feel free to experiment. If we head on over to the preview panel, we'll see our effect layered on top of the segmented tree, both on live video and in a still image. And that's it for this tutorial. It was actually really exciting for me to jump into the Material Graph editor, as that's something I hadn't gotten a chance to do before. And it was a really handy way to experiment with adding AR effects to the segmented object, in our case, the tree. So now that you have a first look at creating on top of a segmentation ML component, I'd really encourage you to jump in and see what you can do. I'm sure you'll come up with something better than my glittery tree. For instance, check out this really cool use of our tree segmentation template from creator Ryan Shields. This ice and fire shader really adds a unique flavor to the template. And share what you come up with any of our pre-trained projects by tweeting us at Fritz Labs. We're excited to see what you'll create. And check out the description below for some helpful resources and more info. That's all for this time. Thanks, everyone.